take a second and let's look at the molecular orbitals of 1,3-butadiene. So as we saw in our lecture, we construct this by putting together an ethylene molecule and another ethylene molecule effectively. And what we get is we get this resultant set of molecular orbitals. So all of these are existing on that molecule. Okay? And these things have labels. So just to reiterate, we call this pi. That's our pi 1. This is your bonding molecular orbital. This is pi 2. So both of these are what we call bonding MOs. Okay? And then coming up above our ground state line right here, we have our pi 3 and our pi 4. Now these orbitals are anti-bonding. So these are anti-bonding MOs. Now, accompanying these orbitals, we end up having a number of nodes too. So to review nodes, we're looking for a change in like sign, right? So a plus to a minus, or sometimes it's indicated by changing color. In this case, like a white color going to a black color. So down here at the bottom, looking at this pi 1, if we're looking at nodes down here, this guy here has 0 nodes. Right, we move up to another orbital, up 1. This has a node right in the middle, right here. So this has 1 node. Okay. Hopping up here to pi 3, it's our anti-bonding orbital. Here we have a change here, right, and a change here. So that's two positions in which we're changing, kind of reading from the left to the right there, a change in our orbitals, right, the colors here. So this is 2 nodes. And then up here to our last, this is our highest energy molecular orbital. It's our anti-bonding orbital. Here we have 1, 2, 3. That gives us 3 nodes. Now you can see the trend there, right? A couple other little pieces of information. So if we look at this and you're asked a question, well, you see this sometimes. How many nodes does the highest energy bonding molecular orbital have? Well, there's a lot of information there. So highest energy, remember we're increasing energy as we go up. Okay, so highest, we're looking for something high. And then it said bonding. So bonding's down here at the bottom. So this is your highest energy bonding molecular orbital. So it would have 1. Sometimes you'll hear a question that says, well, what's the number of nodes that you have in the highest energy molecular orbital? Well, they're probably talking about the anti-bonding orbital there. In that case, you would have 3 nodes. So what about something complicated like this? Well, here we have a molecule with 1, 2, 3, 4, 5 pi bonds, all conjugated. And if we look at this in a little bit more detail, we have this kind of complicated set of the way the orbitals look. Now, pointing this out here, we have 5 orbitals here. These are the bonding MOs. And then this set up here would be your anti-bonding MOs. Right? Anything with a star is going to be your anti-bonding. So if you're asked the number of nodes in the lowest energy, down here, of course it's easy, it's 0. If it's the highest energy, well, it depends. Highest energy bonding or anti-bonding. Well, if it's the bonding molecular orbital, you're looking at that guy right there, right? Because this is pi 5. Right, so then we look and see, okay, well, there's a node right here. There's a node right here, here, and here. So that would have 4 nodes, right? Moving down, here we have 1, 2, 3, right? 1, 2, and then 1 down here at the bottom. So, right, you can see the trend there as we go from 0 all the way up to pi 5, which is your highest energy bonding molecular orbital.